but it's very difficult to see with the naked eye. When you have 800 cheese items and you have some 1,800 items in the delicatessen in a store that's doing $500,000 in business a week, it's very difficult to see those things. It's not something you can see with the naked eye so easily. We need to make it operational. We need a tool. The tool that makes this concept of variation operational, or one of the tools, is the process behavior chart. It's our scale for the variation as opposed to scale for weight. So what we have done is define based on experience and good theory and look at the upper limits and lower limits of predictable variation, and then look at the patterns within those limits. Noise, we know, is ordinary variation. It looks just like a wave. And we saw that before. Most of that chart in the deli, except the first 2 points, is just like a wave. It was just chance variation. So, but special causes, as people have trouble recognizing within the movement of the dots, and so they'll react to things too often. And they're very, very capable of giving explanations of why one went up and another went down. So Wheeler came up with some rules to use, and I like his rules. There's some that have 1,400 rules. I like these are really just 3, and they're very useful. And I found they really work based on a lot of experience. And when you confront a situation where you might have signals in a process behavior chart. The first is if you have 1 point above or below the limits of predictable variation. That's obvious. That means that one cause, you had one thing strong enough to affect the variation enough to go beyond the limits. The second rule is where you have 9 or more points in sequence on the same side of the center line. And it's kind of like a moderately forceful cause or a couple of causes that are exerting influence. And in time, they will get worse if you don't go to and understand it. And the last one is kind of tricky. It's when you have 6 or more points in sequence ascending or descending, which creates what some people call a trend line. It shows a tendency. It may shift a fundamental change in the prophecy. Now, we saw an example like that in the behavior of whom? Absolutely right. And in Messi, I'll go back to him. Excuse me, it'll take a second to get back there. You could see there's a 2, 3, 4, 5, 6. You have 6 in a row, and you can't predict, but you know you need to be looking for. There seems to be a shift in the fundamental behavior, which is what was really happening with them. So it's very important to understand that when the model matches reality, it's very useful. If it doesn't, it's not useful at all. It's dangerous.
So Dan, can I ask a couple questions?
Sure.
Yeah. So this is telling us that when we have 6 or more points in sequence, ascending or descending, this is telling us that this trend is not because of normal variation, right? There's something
correct
special going on here.
Yes, and it may, and the important language is may. It may signal a fundamental change taking place in the process, right?
Okay.
It doesn't necessarily, but it may. That's the tricky part of the things that take place within the upper and lower limit. And when you have a special cause outside the upper and lower limit, it's so extreme there's just no doubt. That's why he built the chart the way he did, is to stop false positives and to ensure that if you saw something that was outside the limit, that you were looking at what he called attributable variation. It wasn't random.
So and did he get to these numbers, like the number 6, like 6 in sequence, ascending or descending, and the number 9 in sequence on the same side of the center line? Is that like a mathematical number where the probability of that happening randomly is
there is
so great?
the math behind it. But quite frankly, I don't think that's the important issue. I think it's experientially, as people have used this is what they found. That's the way I prefer to look at it. Each time you have a certain number of data points showing something, it gives you a confidence level. And based on the number of data points in your universe. But that becomes an area for a lot of argument, which takes place on LinkedIn and between the people who apply it, like me, and the statisticians on how do you apply it. What they found based on experience is that these may be, if they're within the changes with the line, may be influences worth looking at. Does that make sense, David? There's always a battle that takes place in process control charts between the empirical and the theoretical. And I always prefer to come down on the side that Shewhart did. He said, I chose to use 3 sigma as the limits of the variation because it worked. If the math didn't work, then I would not use it because it was based on empirical or experiential observation, what happened on the work floor. So, certainly in number 1, you can know you've got something out of the ordinary. Unpredictable, something, you have chaos entering into the system. Number 2, it's a more moderate force. It's worth looking at and trying to figure out what's happening. Not necessarily to act, but just give it a look. But number 3 is a tricky one because you see people getting charts with trend lines. They're really tricky. They can mislead you. So if I see something like that, I wouldn't exactly sell the farm yet. I might look at it, but I wouldn't exactly sell the farm. Be aware that it might be shifting. We continue. So when we put in the information into the most wonderful XMR process and system behavior chart tool in the world, made and sold by the Deming Collaboration and Mr. Jordi Cabret, we can see in the overall sales of the deli, wow, that's great. It tells us, we have a special cause. Where is it? It's over in the beginning. It's the big line that drops down, and it seems because we have 1, 2, 3, 4, 5, and then another 1, 2, 3, 4, 5. We could be led to believe that we're having some kind of trend taking place, and also on the same side of the center line. So we misinterpret those rules, but it's not true. Why do I say that? Because it's not exactly true, as Hans pointed out, that this 60,000 in Christmas time is really a special cause. It's actually seasonal. If you look at the end of the week, it was the week before Christmas. And in the food and restaurant business, the biggest, it's you do 40% more business than normal during that time. So if you're looking at the pattern overall over the year, you would have a separate season. What should really take place in this is that you not count that week, this season, the holiday season, with what takes place in the rest of the year, because it's a very different reality. The point is to model what's really happens, or what's really happening, not to make the model look good or to be smart. You want to, all models are wrong, but some are useful. You need, once again, that magic word of understanding, context. And that's where the people involved can really make a difference. I mean, I got this once from a statistician once. Well, if you look at the center line, it's off balance. Maybe there's been a shift in your system. It's the old Six Sigma shift. Well, no, it's just that we're including into this model something that should really be in a separate model. And when we take out that season and we look at this chart of the rest of the data, it looks much different.